Okay guys, so this is sketching parabolas, and I'm actually going to split this topic into two separate videos. The first one, this one here, is going to be using the completing the square method to express a quadratic in this form y equals x plus b squared plus c. Okay, and the second video is going to be on how to use this form to actually sketch a parabola. Alright, so let's look at the example that we're going to be doing today. And the example we're given is they want us to express the quadratic y equals 3x squared minus 5x plus 2 in the form y equals a outside of x plus b squared plus c. Okay, and this completing the square method is actually a really cool method. It's a method you can use for any quadratic to factorize it, okay, into an x plus b squared so that we can grab our roots out very quickly. All right, so let's just jump into this example. And what I'm going to do first is just rewrite what we're working with, okay? Just like you do in an exam. Y equals 3x squared minus 5x plus 2. All right, and our first job is we want to look at this x squared value and look at the coefficient of it. So what number lies in front of x squared? And if it's not 1, then we want to take it out the front, okay? We want to take that factor out the front of all of those terms. So in our case, it's 3. So we're going to get y equals 3 outside of x squared minus 5 on 3x plus 2 on 3. Okay, because we notice that if we multiply it back into each term, we get what we started with. All right, and what that step does is it allows us to work with a quadratic that has that 1 in front of the x squared, because that's far easier to factorize. Okay, so our next job is to just look at these x terms, okay? So x squared and x. And what we're going to do is we're just going to work with them by themselves, all right? So let's bring them up here. So we have x squared minus 5 on 3x. And we want them to be in the form x plus b squared, okay? Because that's what we want to use later in our sketching, okay? So that's what this statement says here. How do we get this to that, all right? And it's important you leave a little gap in here, okay? Because that'll come in handy later and I'll show you why. So our next step is just to expand this x plus b squared term out so that we get a quadratic that looks similar to this. So keep our left-hand side the same, x squared minus 5 on 3x with our gap is equal to x squared plus 2bx plus b squared, all right? And what this now allows us to do is compare our left-hand side to the right-hand side. What this is saying is that the quadratic on this side must be exactly equal, that's what this equal sign here is saying, to this right-hand side. Or the coefficient of each of these terms has to be equal, okay? So the coefficient of x squared on this side is equal to the coefficient of x squared on that side. The coefficient of x on this side is equal to the coefficient of x on this side, and this leftover numeral also has to be equal on both sides. Okay, so that's why I got you to leave this gap, because there needs to be a b squared value in there. Okay, another cool thing is that because the coefficient of all these terms is the same, we can compare it. So we can look and we can notice that negative 5 on 3 must be equal to 2b, because the coefficients of x on either side have to be equal. So that gives us a cool little equation. We get negative 5 on 3 is equal to 2b. And from this, we can easily rearrange for what b is. Okay, so we get negative 5 on 6 is equal to b. Just divide that 2 to the other side. So when we look back up here, and we have that b squared term, we can now fill it in and get a final quadratic. We get x squared minus 5 on 3x plus our b term squared, so negative 5 on 6 squared, okay? And this quadratic here is actually going to be able to be factorized in this form x plus b squared. Because what we've essentially done is we've artificially put in this b squared term so that we can look at this quadratic and say what adds to give that and what multiplies to give that, okay? Just like you do with any other quadratic, we're just kind of artificially manipulating the quadratic so that we can factorize it how we want, all right? So, because we were just working with these x terms over here, we can now sub in our new quadratic. This x squared minus 5 on 3x plus negative 5 on 6 squared. And we sub it in for these values here. So basically, take those values in blue out and put in these values in green, okay? So, what we get then is we get y equals 3 outside of x squared minus 5 on 3x plus negative 5 on 6 squared plus 2 on 3, okay? And if you're asking yourself, wait a second, we can't just add a term in. That's not allowed. That's exactly right. We can't just add a term in. If we're going to add a term into this side, we also need to subtract it, okay, so that we keep the expression we started with exactly the same, all right? So what we also have to do is minus negative 5 on 6 squared, okay? And sorry, I'm a little tightly bunched here. But you'll see, you might ask yourself, well, we're just plussing and adding a number. Why would we do that? But what we're going to do now is just look at these terms separately, all right? Because what we'll find is that this term here is going to give us our c value. This term here, like we just did before, is going to factorize to our x plus b squared up here. And then we're going to have this remainder out the front, which is going to be our a value, all right? So let's just do that. Let's just compute. We found before that this in here factorizes to x plus b squared. That was the whole point of this working off to the right hand side, all right? So what we get is we get y equals 3 outside of, we have our x plus b squared term now. So what was our x plus b term? Our b term was negative 5 on 6, so then we get 3 outside of x minus 5 on 6 all squared, okay, that's our x plus b squared term, plus this 2 on 3 minus negative 5 on 6 all squared. Okay, and that's just a number. We can just compute that. And we get 2 on 3 minus, that's 25 on 36. And that gives us minus 1 on 36. Okay? So our final step is just let's bring that 3 back in, and we get y equals 3 outside of x minus 5 on 6 all squared minus 3 on 36, and that simplifies to y equals 3 outside of x minus 5 on 6 all squared minus 1 on 12. Okay? So that's our completing the square method done. And what we find is we have that a value there, that's a, our x plus b term here with negative 5 on 6 being equal to b, and this final term outside here, which is our c value. Okay, so let's write that down. Our a value equals 3, our b value equals negative 5 on 6, and our c value equals negative 1 on 12. All right, because those terms there are going to be super important in our actual sketching of this quadratic, all right? And that is all there is to it. Okay, so good luck, and I'll see you in the next video when we actually sketch this bad boy. On the way down screaming,